Writing down math for a given linear programming work problem is very challenging. So in this video, I want to go over 5 word problems so that we can practice exactly that. The approach that I'm going to take is to make a table and then translate that to math. And for the table, I always have the top row as X, Y, and then available. Now, depending on the context, this might be not just available, or it could also be required, or at least. Okay. And then the table will be about writing constraints here, and then the objective function will be on the bottom row. That's the format I want to write down the table. Alright. First, how do you identify constraints? Well, in a linear programming problem, there's always some kind of constraint which is expressed in terms of some limiting words. So the limiting words are like it can't be more than, it has to be at least, sometimes available. Available is right here. When you see these words, now try to see which ones this is describing. So this is describing the hours for circuit board work cannot be more than 120. So the circuit work cannot be more than 120 hours. And also this applies to the second one, which says the fitting cannot be more than 60 hours. So let's write them down. Here's the circuit and the fitting. And they cannot be more than 120 and 60. Okay, another thing that you have to figure out is what are the variables you're going after. I mean, you're trying to optimize something. To optimize, you're changing some variables until you get the best of something. And often what happens is that the final question has some hints. So here, determine how much of each kind of computers you should make to maximize your revenue. And here you see that how much of each kind. In other words, how much of the cheap computers and how much of the deluxe computers do you want to make. So this will be the cheap, and this will be the deluxe. Okay. Then we can just read on the problem. These sell for $1,500 and $2,400. Oh, this must be about the revenue that you're trying to maximize. Whenever you try to maximize or minimize something, that means you're working with the objective function. And the cheap one has to be 1,500 here. Every cheap product sells for 1,500, and the expensive product will give you 2,400 revenue. Okay, then the next one says cheap model requires 3 hours for circuit board installation and 1 hour to fit the peripheral. Okay, this is about cheap, so it's about this column. Cheap with circuit is 3 hours. Cheap with fitting is 1. So there's 3 and 1. It's like this, okay? So when you fill this in, it's very easy to overlook at words and just blindly just write down 3 and 1 across, and then you're not going to get it right. You have to read closely and see which ones are being talked about while mentioning this 3. This 3 is about circuit and cheap, so it should go here. And this 1 is about fitting and cheap, so it must go here. Okay, in the same way, the deluxe model requires 3 hours of circuit boards and 2 hours of peripherals. So deluxe circuit is 3 and deluxe fitting is 2. Okay, and after this table is completed, writing down the math for it is quite easy. You just write down objective function. What are you trying to do? You're trying to maximize this. Whenever you have this 1,500 or these numbers, that gets the first columns, the number gets multiplied to your x. In the second column, the number gets multiplied to y. So it will be 1,500x plus 2,400y, and that's your objective function. You're trying to maximize this. And then each of your constraints just become inequalities. So you have 3x plus 3y less or equal to 120, and x plus 2y less or equal to 60. And then even if it's not on the table, usually you want to say that your x and y are non-negative, because it doesn't make sense to produce negative number of computers. So that's how you do it. Alright, let's go to the second question. Here is another question. We see that in the final question it's asking about what ratio of belts and wallets will produce the most profit. So it's actually asking about how many belts to make and how many wallets to make. Okay, that's good. Let's write down the table. X, Y, available. Okay, and then we have to look for the constraints now. It says, oh, again, available. Very good. Okay, and then we have the cutting is 12 hours. Sewing is 18 hours. So we'll write down cutting is limited to 12 hours, and sewing is limited to 18 hours. Okay? And then we read from the beginning. Each belt nets the company $18 in profit, and wallet nets $12. These are the easiest. Usually you have some money attached, and you're trying to produce something, maximizing either revenue or the profit. So the objective function is money. Okay, so you have objective function here, $18 for your x. We decide to make x as the belts, right, and then y as the wallets. Okay, so here the wallets is 12, and then we read on. Belts require 2 hours of cutting and 6 hours of sewing. So belts, 2 hours of cutting and 6 hours sewing. Okay, and then wallets require 3 hours of cutting and 3 hours of sewing. So 3 hours wallets and cutting is 3, wallets and sewing is 3. Alright, and then now you write down objective function. You want to maximize, because it says most, right? Maximize 18x plus 12y, with each of these transformed into inequalities, which says 2x plus 3y has to be less or equal to 12, and 6x plus 18y has to be less, no, sorry, it should be 3y has to be less or equal to 18, and then x and y cannot be negative. Now in question 3, it's a little different. The first two were kind of typical and easy, and now here, rather than trying to maximize something, it's trying to minimize something, and the words will be slightly different. Okay, so let's first read the last part. It says, how many days per week should the county open each center? So it's asking for how many days to open each center, and there are 2 centers. If you read here, there's center 1, we should take that as x, and center 2 should be your y. So x would mean how many days to open, how many days to open center 1, and y will be likewise. Let's write down the table as we always have been, x, y, and available. And since we've identified what x and y are, now let's go for the constraints. What is constraining anything? Well, you see this word at least, right? Okay, I don't see anything else. So it says at least this much of glass. So this at least is being applied to this glass being at least this, and aluminum being at least 1440. Okay. So glass and aluminum are the 2 constraints, And what you have to be careful here is that this is not about 1540 being available. So that's somewhat different than before. So instead of 1540 being available, it's required. This is the least it has to be. So sometimes this column can be available, sometimes it means it's required. So I guess you want to write down available / required, but often I'll just write down available and not write down required because I just want to save time. But that really does something when you write down the inequalities, because before, when we had available, we just always thought that this should be this way, right? In the previous questions we had like that. But here, the glass has to be at least 1540, so the inequality changes. So you have to be careful here. So it's good to write down these inequalities when you see that it's not simply, this side is not simply the maximum. If it's at least, then try writing down the inequalities so they don't get confused later. Alright, so let's try to read. Center 1 costs $40 to run. $40 has nothing to do with the glass or aluminum. It actually has to do with the cost, and you're trying to minimize the cost, right? So the 40 actually applies to the cost, which we're trying to minimize. So cost for X is 40. And then this is about center 1, right? This is center 1. Let's just write down 1 and 2. 1 is 40. And then 140 pounds of glass. So 140 for glass. 1 and glass is 140. And then 60 pounds of aluminum. So 1 and aluminum is 60. Then here, Y is the center 2. It's here. $50 to operate. And then 100 pounds of glass. So center 2 and glass is 100. And then center 2 and aluminum is 180. Okay, now we have written the table. Let's write down the math. Objective function is to minimize 40x plus 50y. And then the constraints, these become inequalities. 140x plus 100y has to be at least 1540. And then this should be 60x plus 180y and at least 1440. Okay, and then as usual we put xy has to be non-negative. Alright, so let's try another type. Here, if you look at the last sentence, it says, how many tourist class seats? That's the question. And if you read this question again, you see that actually there are two types of seats. There's the business class seat and tourist class seat. Okay, and probably when you try to maximize profit, you will likely figure out the number of business class seats and tourist seats anyways. So we are going to say this is our x and this is our y. So x is business and y is tourist. And then once again I'll just write available, although it could be required. Okay, available or required is right here. Alright. Okay, then let's read on. Oh wait, well, we have to figure out these limiting words for constraints, right? So do you see something? Oh, okay, I see at least. I see another at least. And then does not hold more than, oh that's tricky, does not hold more than 30 passengers. These restrict resources, or it requires some resources, right? So these are limiting words. We have to figure out what they are applying to. This at least is applying to business class seats, and it has to be at least 5. And this at least says tourist seats has to be at least 9. And this last one applies that the passengers has to be at most 30. Okay. So given that, we should be writing down the constraints. It's business, and then it's limiting the tourists, and then it's also limiting the number of passengers. Okay. Now, the business has to be at least 5, so like before, let's try to write down the operators too. So it has to be at least 5. It has to be at least, this one, the tourist has to be at least 9. But the passengers has to be no more than 30, so that's at most 30. Okay. So in this case, writing down the inequality is crucial if you don't want to mess up later. Okay. Now here comes the challenging part. This question is more challenging than the previous one because already we have the business as X and tourists as Y, right? And you're just trying to see what business, we are trying to say that business has to be greater or equal to 5. So that requires some thinking. Business by itself is what? X by itself, so this is really, you're trying to say X has to be less or equals to 5, right? For the table, X is same as 1 times X plus 0 times Y, because 0 times anything is 0. So you can write down 1 and 0 for the table. Okay? And also the tourist, it's just this by itself, so you put 0 and 1 for the tourist. And the passengers is the sum of X and Y, right? This one really, you want to say X plus Y. The business and the tourist adds up to be the total passengers. And since this is 1 times X plus 1 times Y, 1 and 1 are the coefficients. Alright? Okay, and then it says Fly High makes $40 profit for each. So the profit here is $40. Yeah, we used to say just objective function here, right? Objective is $40 and 45. Okay, that's your objective function. Now let's try to write down the math. Objective function is to maximize our profit, which is 40x plus 45y. And then x by itself has to be greater or equals to 5. Y by itself has to be greater than 9. Right? And then x plus y has to be at most 30. And the x and y cannot be negative. Okay. The final question here, how many students tickets should they sell? So it's about like number of tickets to be sold and what kind of tickets are there. So there are the general admission tickets. So general tickets is here, and then student tickets is also here. Okay, good. Let's call that Y, student tickets. All right, so we have X, Y, available, required here. Okay, and then we'll try to find the constraints. Okay, where the X is the general and Y is the student. Okay. I see the word no more. Very good. So it's about general admission. So the general admission tickets has a limit. So that means we should write down general has the limit of what, 2,000, and that's maximum, right? No more than. Okay, then we see another no more. Okay, no more than, right? No more than. Student tickets should be limited to 4,000. So we put student 4,000. Less or equal to. And then, is there anything else? Oh, it has a budget of 3,000. That's a tricky word. You really have to read this carefully. The dance company has a budget of 3,000. So it's saying that you can't spend more money than 3,000. So the budget will be another constraint. I've been writing in red, so let me write in red. The budget cannot be more than 3,000. Okay. And then find the maximum profit, and it talks about $4. So objective function is the profit. Alright, so let's try to work this out. For the general ticket itself has to be less or equal to 2,000, right? So according to school policy, 2,000 general admission tickets is the limit for the general. So X itself has to be less or equal to 2,000. So you put 1 and 0. 1, 0 means X itself. And then it says 4,000 student tickets can be sold. So 0, 1 means Y itself. Y has to be less or equal to 4,000. And then there's the budget, or the advertising budget, and it costs 50 cents for the general. So budget for oh no, I almost got tricked here, right? It says student, right? That's why you have to be careful. So 50 cents for student. So the advertising budget for student is, it gives you 50 cents. So maybe advertising cost, that's the one that you should say. So advertising cost is 50 cents per student and $1 for general public. So it's 1 here. Okay. And then finally it says every student one you get $4 of profit. For every general you get $7 of profit. Okay. So we are almost done now. Objective function is to maximize the profit, which is 7x plus 4y. And then the inequalities are each x has to be less or equals to 2,000, y has to be less or equal to 4,000. And then the last one, it's 1 times x plus 0.50 times y has to be less or equals to 3,000. And then finally you just say x and y has to be non-negative. Done. That's how you do these word problems. Hopefully these were enough examples to give you some confidence about writing down math for each of the word problems.